Hi, my name is Tim Nelson, and I'm here to demonstrate my knowledge of parabolic equations and their application to real life. Now I'm working on this project with a group of close friends of mine, Justin Phelan and Tommy Scott. But first, before we get started on this project, I would like to introduce to you my partner, who I have been working with for quite some time, Da Vinci. Now Da Vinci and I, as I've said, have been working together for a very long time. He's a good friend of mine, so of course he's agreed to help me out with this. And now I would like to demonstrate to you how we are going to demonstrate our knowledge of parabolic equations.
Now, as I said, I'm going to be demonstrating this device I was just talking about. But first, excuse me, I would like to avoid any unnecessary pain to our good friend Da Vinci here. So we'll not be using Da Vinci in our demonstration. See you later, Da Vinci. Instead, we're going to be using an inanimate object, a basketball. And now, for the demonstration. Boy, it sure is cold out here. I wish I had another, maybe more brightly colored coat. Wow! Due to slight technical difficulties, there's been a slight change of plan in the method of launch. This is our new method. An aluminum baseball bat.
Now we're going to be coming inside because of bad weather conditions outside for our real test, where we're going to be using my good friend Da Vinci. Well, I'm glad to have a great friend like Da Vinci who is willing to suffer like that just for math. Now, as you saw on the graph we made on the garage door, we had 3 points of intersection. At 5 and 0, at 4 and 1, and at 1 and 1. The next thing we did is plug those into the general form, which is y equals ax squared plus bx plus c. Now the first one read 0 equals 25a plus 5b plus c. The second, 1 equals 16a plus 4b plus c. And the third, 1 equals a plus b plus c. Now that we have these equations, we plug the numbers into a matrix. And the matrix, which is 3 by 3, will look like this. 25, 5, and 1 on the first row. 16, 4, and 1 on the second row. And 1, 1, and 1 on the third row. Now, after we do this, we make another matrix, this one a 3 by 1. This matrix will be 0, 1, and 1, representing the y values in the equations. Then we plug this into our calculator, the a and b matrices respectively, and it will look like this, a to the negative 1 times b. And what we get from this is the answers to a, b, and c in the general form equation. A, in this case, representing negative 0.25, b, 1.25, and c is 0. If you were to do this on the calculator, the 3 by 3 matrix would be a, and the 3 by 1 would be b. So to solve, you would type in a to the negative first times b. And what you get from that, in the final stage of our equation, is a is equal to negative 0.25, b is equal to 1.25, and c is equal to 0. So then our equation will look like this. Negative 0.25 x squared plus 1.25x. For the sake of time, I'm not going to personally explain in detail all the things that we've done. Instead, I'll make them flash on your screen. Now, for the vertex form. And finally, for this equation, the x-intercept form. Now, the equation for the vertical velocity. And now, finally, the equation for the horizontal velocity. And now, on behalf of myself, Da Vinci, and my group, I would like to thank you for watching this video. Goodbye.
I have rabies.
I'm Tommy's head and I